Hi everyone, Sir Amboy here, and welcome once again to my lecture series in Integral Calculus. So we may recall that the very origin of integral calculus is the area problem, which originated some hundreds of years before Christ during the times of Archimedes. Now in this episode, I will teach you how to obtain and calculate the area under the graph of a function by means of integration, which I think is the most significant application of the definite integral. So, let's get started. Consider the graph of the function y equals f of x, and you want to get the area under the graph of this function in the closed interval a to b. So here is the area, the one shaded in the pink region. So gay. Now, how are we going to get the area of this pink region? So in order to do this, we will divide this entire area into infinitely many rectangles. Okay, so that's it, infinitely many. So napakadami nun. Kung napakadami nun, edi sobrang nipis pala nila. Yes, okay. And for the sake of illustration, let this rectangle be one of them. So here is a representative rectangle. Okay, so this rectangle has a length and a width. Okay, but its width is very, very thin because they are infinitely many. But the length of this rectangle varies depending on the value of the function. For example, this rectangle is placed here instead. Its length would be the value of the function at this point. If this rectangle is placed here, then its length from here to there would be the value of the function here at this point. That is why its length is represented by the value of the function y. Okay, so we let the length of the rectangle be equal to the value of the function at any point on this graph, and that is y. From here on, we will refer to a representative rectangle like this as a differential area, or simply a strip. And since there are infinitely many rectangles like this, it follows that their width would be infinitely thin. So kung infinitely many ang mga rectangle na ito, yung kanilang width ay infinitely thin din. Okay, so approaching zero. And because of that, we will represent the width as a differential. We will call it the differential of x. So this dx represents the width of the rectangle. It's a differential because it approaches zero. And it's dx because, of course, it's along the x-axis. So now, we can express the area of the strip as dA, an infinitely small area, which we call the differential area element, as of course the product of the length and the width. That's why here we have y times dx. Now, to get the entire area, we will have to add the areas of all the infinitely thin rectangles. Of course, practically speaking, we cannot add infinitely many quantities, but mathematically, we can do this by means of integration. So that's the power of mathematics. There are things which you cannot do in real life, which you can do with the aid of mathematics. So the total area thus can be obtained by integrating this expression. So mathematically, if I integrate both sides here, I will get A, which represents the total area under the curve in the interval a to b. And I also integrate the right side, which will give me the integral of y dx, which we will evaluate from a to b. Okay, here, a is the lower limit, which is the value of x at this point, and b is the upper limit, which is the value of b at this point. Okay, so we have to take note that since here, the variable of integration is x, the values of our limits, the lower and the upper limit, must be values of x. So now this is the formula for finding the area under a curve. It's just the integral of the given function times dx, evaluated from a to b. A and b are the boundaries that would serve as the edges of the area. Okay? I think that's very simple. It's just the integral of y dx. Now, there might be some cases wherein it's impractical to use a vertical differential area element. That is why sometimes there would be situations in which we will use a horizontal differential area element instead of a vertical one. So if the situation calls for a horizontal strip like this, then what would be the dimensions of our differential area, or simply the strip? Of course, its length would be from here to there, which is the value of the function, which is x. So the length of this strip would be the value of x. Okay, it could be the value of x here if your strip is there, or it could be the value of x here if your strip is here instead of being there. Okay, so we simply let its length be equal to L. Now, how about its width? Its width is now the differential of y dy. Now, what would be the expression for finding the area of this single area element? It would be the length x multiplied by the width dy. So that would be our expression for dA. The differential area element is equal to x dy, and to get the area of the entire region, which is colored in yellow, we will integrate both sides to get the total area A, which is equal to the integral of x dy evaluated from A to B. Now, we may notice that here, our differential is now dy instead of what we have before, which is dx. So, since the variable of integration is y, the values of the lower limit and the upper limit must also be values of y. So here, a is the value of y here, and b is the value of y at this point. Okay, so we evaluate the integral from a to b, wherein a and b are values of y since we are integrating with respect to y. So to illustrate how to use these formulas, I will give you several examples in the coming slide. Okay, so let us solve the first example. So here's the problem. Find the area under the graph of y equals x plus 2 and the x-axis from x equals -1 to x equals 5. Okay, so before we solve the problem, let us first take a look at the bigger picture. Here, the given function is actually a line, and to graph the line, we let the value of x here be equal to 0, and if x is 0, y is 2. So we have the first point, 0, 2. Okay, now this time, let's make y 0. If y equals 0 here, the value of x would be -2. Okay, so the second point is -2, 0. So these points are sufficient for us to graph this function. So the graph would look like this. So here is the first point, 0, 2. And this is the second point, -2, 0. So we just connect these points to form the line and extend towards the right because we are interested in solving the area from x equals -1, which is here. This would serve as our lower limit, up to x equals 5 there, which would serve as our upper limit. So this region, the one shaded in dark green, is the area that we will be calculating. Now actually, without integration, we can determine the area because this is geometrically a triangle. And we know the formula for finding the area of a triangle, it's just 1/2 of the base times the height. Of course, we'll not be using that because we are studying calculus. Of course, we'll get the area by means of integration. Okay, so now, how are we going to get the area of this green region by means of integration? First, we will assign a differential area element. Let's use a vertical differential area. Okay, and let's label its dimensions. Here, the length of the differential area is y. That's the value of the function at this point. And then, of course, its thickness would be the differential of x. So now, if you recall, the formula for finding the area under the graph of a function, that's just the integral of y times dx. And since here, the variable of integration is x, we need to express y as a function of x and indicate the lower and the upper limits. Okay, so here, y will be replaced by x plus 2 because from the given function, y equals x plus 2. So I'll just copy that, x plus 2 and dx. Now, the lower limit is given, it's -1, and the upper limit is also given, the value is 5. Okay, so the next step to do is to evaluate this definite integral. Okay, so let us integrate. We will have x squared over 2 plus 2x. And we have to evaluate this from -1 to 5. Okay, so we know that in evaluating a definite integral, it's always the upper limit minus the lower limit. Okay, so I'll just replace this x by 5 and square it. So that's 25 over 2 plus 2 times 5, that's 10. Okay, minus the lower limit, which is -1. So if I square -1, I will get 1. And then plus 2 times -1. Okay. So now I have here 25 over 2. The area is now 25 over 2 plus 10 minus, this is 1/2 minus 2, which is -3/2. And negative of negative will give us positive. So positive 3/2. So we can combine these two fractions because they are similar. 25 over 2 plus 3/2, I will get 28 over 2. And 28 over 2 is 14 plus 10. I will get the total area, which is now equal to 24 square units. Okay, so this is now the area of this green region. Okay, so ganun lang kadaling kumuha ng area under the curve. Integrate mo lang. Integral of y dx, evaluate, no, from the lower limit up to the upper limit. O, di ba? Sobrang dali lang. Okay, so as an exercise, pwede mong kunin yung area ng triangle na malaki minus yung area ng triangle na maliit, and you should get 24 as well. Okay, so let's proceed to the next example. Example number 2. Find the area bounded by y equals 4 minus x squared in the first quadrant. Just like what we did in the previous one, we should take a look at the bigger picture here. The given function is a parabola because this is a quadratic function. And we may notice that y and x squared have opposite signs, which means that this parabola is opening downwards. So we can accurately graph this parabola. We need to express it in its standard form. And recall the standard form of a parabola. That's x minus h squared equals 4a times y minus k. O, diba? Kailangan. Saulo mo yan. O, ngayon. Itong parabola na ito na given, i-express natin na ganito ang itsura. Okay, let's express this in this form. Okay, so we'll have to transpose this term on the left. So we'll have x squared equals, so we'll get here negative y plus 4. Okay, now this can be written as x squared equals the negative of y minus 4. So that when I distribute the negative sign, I'll get negative y, just like it's negative here, and negative of negative will be positive. So it's positive. So these two are identical to each other. So from this standard form, we are now sure that the vertex of this parabola is at 0, because here there is no h term, so h is 0, and the value of k is 4, so 0, 4. And since this is negative, it is opening downwards, no? As what we have mentioned a while ago. So this is now the vertex of the parabola, 0, 4, and it's opening downward. So if we graph the parabola, it would look like this. Okay, so this is now the parabola. The problem says that we find the area bounded by this parabola in the first quadrant. So that means that aside from this parabola, the boundaries would be the x-axis and the y-axis, because we are concerned only with the area in the first quadrant. So it is implied that the y-axis and again the x-axis are also our boundaries. To solve the problem, we need to use a differential area element, and for this problem we can use a vertical differential area. So let's label the differential area. Its length can be represented as y, and its thickness can be represented as dx. So the differential area dA is now equal to y dx. And again, to get the area of the entire shaded region, we need to integrate both sides of the equation. So the area is now equal to the integral of y dx. And again, because we are integrating with x, we need to express y as a function of x. And where can we get that? From the given function, of course. Y here is equal to 4 minus x squared. Ayun, isaksak mo lang dyan. Palitan mo siya. O ngayon, integral of 4 minus x squared. And then, of course, we copy dx. And now let's indicate the limits. The limit of integration is very obvious because we can see it in the graph. That would be from 0 to 2. Sir, what if my graph is not that accurate? I do not know the points of intersection. So what you're going to do is to equate this to 0. Why? Because at these points, the value of y is 0. So we just equate 4 minus x squared to 0 and then solve for x. If we solve for x, that's the square root of 4, and we know that we will get two values because of course the square root of 4 has two values, positive and negative 2. Okay, but since we are only interested with the area on the first quadrant, so this is the negative 2 that we obtained there. Okay, so since we are interested only with the area on the first quadrant, we will not integrate from negative 2. Rather, we'll integrate from 0. And the upper limit would be 2. So, positive 2. That's why, in the graph, we have positive 2 there. Okay? So, even your graph is not that accurate, you can still determine the upper limit. So, let's now integrate from 0 to 2. Okay? Now, let's integrate. The area equals, okay, so 4x minus x cubed over 3. And let's evaluate this from 0 to 2. Okay, so the area is now equal to, so if I replace this x with 2, I'll get 8 minus, so 2 cubed is 8, so 8 over 3, and then minus, if these x's here are replaced by 0, I will get 0. So we can now get the area. Okay, this can be written as, of course, our common denominator is 3. And here, we will have 24 minus 8. Okay? So 24 minus 8 is 16 and then over 3. So this is now our area. Okay? So the area of this green region is 16 over 3 square units. O, diba? Simple lang. Actually, there is a shortcut for finding the area of a parabolic segment. Okay, so for your information, the area of the green region here, this green region is called a segment. It's a parabolic segment. And the shortcut formula for the area of a parabolic segment is 2/3 BH. Okay, let us see. If we'll get the same answer, that's 2/3 times the base. So the base is the length from here to there. So that's 2. And the height is from 0 to there. So that's 4. Okay. So that's 2 times 2, which is 4 times 4, which is 16. So the answer is the same. It's also 16/3. So the next time you encounter a problem that requires you to find the area of a parabolic segment, you already know the shortcut formula. O, diba? Madali lang. 2/3 BH. Ngayon, what if ayaw kong gumamit ng vertical area element, no? Instead, I want to use a horizontal area element. Just like this. Okay? Sir, yun bang area na makukuha ko kung gagamit ako ng horizontal area element? Parehas lang? Yes. Dapat parehas lang, no? So if your solution is mathematically correct, you should be able to get the same answer. Now let's do that in the next slide. Okay? So we will solve the same problem, but this time instead of using a vertical differential area, gagamit tayo ng horizontal strip. O, diba? O, ngayon, itong horizontal strip na ito, hindi siya naghubad, hindi siya nag-strip, ha? Ano ang length niya? Of course, its length would be x. Hindi mo na siya mahal kasi x mo na siya, no? And now its width is the differential of y. So ngayon, ano na ang ating differential area element, dA? O di natural, that's the length times the width. Simple lang. That's x times dy. And of course, to get the area of the total area rather, we just integrate both sides, and here we'll get x times dy. So notice here that our differential is now dy, okay? And the variable of integration is y. That is why there is a need for us to express this x in terms of y. Shit! Paano ko gagawin yun? Madali lang. Tingnan mo yung given problem. Y equals 4 minus x squared. O, diba? So, you just solve for x. Ay, paano yun? Ilipat mo siya. Gawin mo siyang x squared. Tapos, gawin mong 4 minus y. That's it. Okay, to get x, you just get the square root of both sides. So, x is now equal to the square root of 4 minus y. Ayan na siya. Gamitin mo siya here. Ay! Yung x palitan mo ng square root of 4 minus y. And then dy. Okay? So, now, we need to indicate the limits. And remember, this is dy. So, the values of our limits must be values of y. Kanina ang ginamit natin from 0 to 2. Bakit? Kasi dx yon. Pero ngayon, hindi na. Okay, dapat ang lower limit value ng y. So here, the value of y is still 0. Okay, so what will be our upper limit? Ang upper limit mo dapat dito. Okay, here, what's the value of y? 4. Sir, paano ko malalaman yun? O, di tingnan mo sa graph, ayan, malinaw. Anong value ng y dito? 4. Sir, paano pag hindi ko yun alam? Actually, dapat alam mo kasi vertex siya ng parabola. Di ba nakuha natin kanina? Anong vertex ng parabola? 0, 4. O, ayan, no? Okay, yan yung kailangan mo na upper limit. Okay, so ngayon mag-integrate na tayo. Okay, integrating this manually. Okay, we can use the substitution method if I let this be equal to u. Okay, so my u is equal to 4 minus y. Then my du would be negative of dy. And I can express this as the integral of u raised to 1/2 and then dy. Okay? May negative sign doon. Okay? Because here, dy is the negative of du. Sorry, it should not be dy. Rather, it should be du. Okay? Du. Ayan. So, we can now integrate. The area is the negative of u to the 1/2. Pag in-integrate mo, magiging u to the 3/2. Yung exponent, kunin mo lang ang reciprocal. So, magiging 2/3 times u raised to 3/2. Okay. Now, using back substitution, because our original variable is y, not u, we replace this with, okay, a is equal to negative 2/3 thirds times, yung u na ginamit ko kanina is 4 minus y. So, 4 minus y. And then, erase ko daw siya sa 3 halves. Okay, so ito ngayon ang i-evaluate ko from 0 to 4. So, let's now evaluate the area from 0 to 4. Okay, so the area is now equal to negative 2/3 times, okay, so here, if I replace y by 4, I will get 0. Okay, so that's 0. Minus the upper limit, which is, okay, negative of negative will be positive. So, positive 2/3. And then, 4 minus 0. So, that's 4 raised to 3 halves. So, this term will vanish. It will be 0. And the area we will get is 2/3 of 4 raised to 3 halves. 4 raised to 3 halves is actually the square root of 4, which is 2. And then cube, which is 8. Okay? So, 8 times 2 is 16. Divided by 3, we get the same area which we obtained in the previous slide. So, the area is just the same. Okay? So, we have 16 over 3 square units. Okay? So, this is the area of this green region. Okay? Now, we are able to prove that if you use whether a vertical strip or a horizontal strip, for as long as you are doing your solution mathematically correct, you should be able to get the same answer. Horizontal strip man yan or vertical strip. Kung parehas lang problem, dapat parehas lang ang sagot. Okay? So, in the next episode, ang ituturo ko naman sa inyo is kung paano mag-compute ng area if ang area ay bounded by 2 different curves. Dito kasi isang curve lang yung given, no? The other boundary is the x-axis and the y-axis. But in the next topic, for example, meron tayong parabola opening upward at meron tayong parabola opening downward. And then, we are interested to find the area between them. For example, i-shade natin itong kulay na ito, itong region na ito. Yan. So this is the area that we will be solving. Okay, and this is now between the two curves. We have the parabola opening downward and the parabola opening upwards. Okay, so next topic, mga ganyang problem ang aking isa-solve. Okay? So, abangan nyo yan sa aking susunod na video. Okay? Bye! Charot!